Okay, welcome back. Now, here's the right endpoint approximation. So again, all I did was change the wording a little bit and the notation. So here's what I'm going to do. Okay, so I'm going to show you the curve. So if we draw the curve, like so. Okay, so here's our axes, X and Y. And so let's say we have this curve. And so here's A and B. And so what we would do is we would now use these subintervals. And now we're going to use the right endpoint. Okay, so let me just put this here. So now what I'm going to do is I'm going to use the right endpoint of the subintervals. So I'm going to use this to mark the height of the rectangle. And then I'm going to use this one to mark the height of the rectangle. And then this one. And then this one. And then this one. And then this one. Okay? So that's the difference, is now all I'm doing, instead of using the left endpoint of each subinterval to construct the height of my rectangle, I'm using the right endpoint. So again, so this is rule number 4 for doing right endpoint approximation. So again, it says on each subinterval, x sub I minus 1 to x sub I, for I equals 1 to n, we're going to construct a rectangle with width delta x. Again, we're doing a regular partition. And the height is going to equal to f of x sub I now, not x sub I minus 1, because now we're doing the right endpoint. So x sub I is what we're going to use to find the height of the rectangle, which is at f of x sub I. Okay? And again, this is evaluated at the right endpoint of the subinterval. Then the area of the rectangle is going to be given by f of x sub I times delta x. And then we add these areas of these rectangles to give an approximate value of the area A, just like before. And now in this case, we're going to use capital R sub n to denote the right endpoint approximation. And so we can say that A is approximately equal to R sub n, which is given by f of x sub 1 times delta x plus f of x sub 2 times delta x all the way to f of x sub n delta x. And of course, we can write as a summation here as the summation of I equals 1 to n of f of x sub I, the right endpoint, times delta x. Okay? So there you go. Now we've got two ways we can approximate an area under the curve. We could use the left endpoint approximation or the right endpoint approximation. And there's more to come. Have a good day.